Good day to everyone. This is the project 2 for the Logic Gate and Switching Theory Laboratory, which is a 4-bit calculator that can either perform addition, subtraction, multiplication between two inputs. This project is constructed and designed through the use of logic gates such as AND, OR, NOR, XOR, XNOR, and NOT gates. For the first part of this project is constructing the decoder circuit for the two sets of 4-bit inputs to the 7-segment display, 2 for each input, and the input regions from 0 to 15 since it has 4 bits. For this case, logic gate equivalent of 4 times 16 line decoder is utilized. Next up is constructing the adder and subtractor circuit with sub as control that can use the user for choose a certain operation, whether addition or subtraction. Next group of circuit, it is used to decode 5-bit output from the adder and subtractor to the output display. This circuit can decode the 1's digit and the 10's digit for each segment for two separate 7-segment displays. Since we are now done for addition and subtraction, we move on to the multiplication. In this case, we use the 4-bit multiplier that utilizes 3 separate adders, and we use each logic gate equivalent, of course, due to the limitation for the rules of this project. And it can have an output up to 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This circuit can multiply up to 2 4-bit inputs. After getting the raw product, we have to convert that number into its BCD notation for easy decoding. In this case, for this circuit, it uses the double-double algorithm theory, which involves steps with shifting the binary numbers to the left and adding 3 to that shifted number. For the add 3 module, this is the logic gate equivalent for that module. And we connect series of that module, and then we have an output of 4 bit for ones, 4 bit for tens, and 2 bits for the hundreds digit, where we can decode it easily to the 3 7-segment display. After converting the circuit into its BCD notation, we can now easily decode the product by using 2 4-bit to BCD decoder, which is used in project 1, 1 for 1's digit, and 1 for 10's digit. For the hundreds, since it has only 2 bits, now we can use another logic circuit for that, which is simpler. To switch the display at a 3 7-segment display output between sum and difference or product, we also use 3 separate group switches using a series of NAND gates, 1 for each digit. With a mult network as the control, it can switch display between sum and difference or product for each segments. For the actual testing of our calculator, we first input 0011, the first number, and 0010 at the second number. The input decodes 3 and 2. If we put 1 at the addition interface, which is to add the number, the result will be 5. And if we off the add and on the subtract, we have to subtract the number 3 minus 2, which is equals to 1. And then if you multiply it, 3 times 2, so the answer will be 06. For the next set of numbers, we have to put 1000 and 000110. The decoded input is 8 and 6. If you add the numbers, we should get 14. And if you subtract, you have 2. If you multiply it, 8 times 6, so 48. Next set of numbers, 1101 and 0111. Decoded input will be 13 and 7. If we add the numbers, the answer is 20. If you subtract it, the answer is 6. Then if you multiply it, the answer will be 91. Another set of numbers is 11011 and 100. Decoded input should be 11 and 9. 11 and 8 rather. If we add it, it is equals to 19. Then if you subtract it, the answer will be 3. And then if you multiply it, the answer will be 88. The next number, you should test it to the max numbers, which is 1111 and 1111, which is decode 15 and 15. If we add the numbers, the answer will be 30. If you subtract it, and then the answer will be 0. If we multiply it, the answer will be 225. For another number, I have to put 1100 and 1100, 1110 rather, and 1100. It will decode 14 and 12. If we add the numbers, then we should get 26. If we subtract the numbers, we have the answer of 2. And if we multiply it, we have to get 168. For the last set of numbers, we have to input 1101 and 1010. This should decode 13 and 10. If we add the numbers, we should get 23. If we subtract it, then we should get 3. If you multiply 13 and 10, the answer will be 130. Then we up it again. We bring back to 0. So it decodes 0 and 0 and 0. So that is all for this project, which is a mini calculator that can perform addition, subtraction, and multiplication. Project 2 for Logic Bits and Switching Theory Laboratory. Thank you very much.